Yeah, good morning, children. We are going to discuss today exercise 6B. So, what is the main objective of this exercise is? So, in the previous one, 6A, we used differentiation to calculate the velocity when displacement is given as a function of time. But here, use differentiation to calculate acceleration when velocity is given as a function of time. So, you can find here the velocity of an object, so they have given, so please note down first given quantities. So what is given v is equal to 5t square minus 20. So we have to differentiate, so that means we have to find the acceleration. So how to find the acceleration? They're asking to find the time when the particle is stationary. So when the particle is stationary means what happened to its speed. So here v should be equal to 0, okay, because it's not moving, because particle is stationary. So what is the meaning of particle is stationary? The object is not moving. So therefore just put v is equal to 0 in the above equation. So 0 is equal to 5t square minus 20. That implies 5t square is equal to 20. That implies t square is equal to 4. Therefore t is equal to 2 seconds. So this is the answer for the first one. Next. So here we don't need to do differentiation because they didn't ask us to find the acceleration. Now move on to the next question. So we'll do the question number 3. A tennis ball travels vertically upwards in a straight line. The velocity of the ball in the upward direction is given as v. At time t is equal to seconds, the equation is given as, so given velocity is equal to 20 minus 10 into t. So find the acceleration of the ball and interpret your result. So first we will do the part A. So to find the acceleration, we have to differentiate this with respect to time. So A is equal to dv by dt. That is equal to d by dt of v. What is v? 20 minus 10 into t. Now 20 is a constant. So what happened to a derivative of constant? So if you want, you can write separately d by dt of 20 minus 10 into d by dt of t. Obviously derivative of constant will be 0. Therefore 0 minus 10 into d by dt of t is 1. So which is minus 10. So therefore here acceleration is minus 10 meter second power minus 2. So this is the answer for this. So the acceleration. So then the second part they're asking, so what is the assumption? Interpret your result. So what is the result here? This is the acceleration due to gravity. Since you got minus, that means this is the acceleration due to gravity. Due to gravity. Then why this value we got negative? That means it is negative because, yeah, when object is moving against the gravity, that means acceleration will be negative because the upward direction is, yeah. Next, move on to the question number 5. So these are like in the previous exercise also, one of the questions like they gave three different conditions, so with time intervals. So like here also, this velocity we can use between 0 and 1 seconds, this, right? And also we can use the velocity equation even for 1 second. We can use also 6 minus t square, and maximum is 1.2. And this function also we can use for 1.2 and the maximum of time period t seconds. Okay, so so using this we have to work out, yeah. So obviously here you see that the boy velocity is 0 meter per second at time t. That means he must be at rest. So a boy runs in a straight line. The velocity of the boy is v meter per second. a time t is given by, so there are three functions, three equations given in terms of time, velocity. So work out the value of k. So that k value we have to find. Okay. So first you can choose a common time, right? So when time t is equal to, what is the common time? First it is, let us take 1 point, because you find the k value. What are the, which equation is using k value here? 5 minus k by 30, this one. So what is the time it involves here? 1.2. And another equation, 6 minus t square, also has a time 1.2 seconds. So at time 1.2 seconds, so you can equate both the velocity equations, because one equation is v is equal to 6 minus t square, and another equation which involves k at 1.2 second is 5 minus k by 30 into t. That is the reason why I am taking these two. Okay, now equate both of them. So 6 minus t square is equal to 5 minus k by 30 into t. Now simplify it further. So bring the terms one side. So this is 5 and this is 6, right? They are numbers. So if you substitute in place of t 1.2, 6 minus 1.2 whole square is equal to 5 minus k by 30 into, in the place of t you can substitute 1.2. Now simplify this further. What will get? So 6 minus 1.2 square. So what is the 1.2 square? So 1.2 square, it is equal to 1.44. Yeah. So 6 minus 6, that will be equal to 4.56. Yeah. Minus, if you take this 5 the other side, or minus 5 is equal to minus k into 1.2 divided by 30. So which is 0.04, minus k into 0.04. So simplify this, what will get? So 4.56 minus 5, which is minus 0.44, divided by 0.404 is equal to minus k. So minus minus cancel out. Now what is the k value will get? So it is 11. Therefore that implies k value, the constant value is 11. So this is the first part they're asking us to prove. So we have done with the first part. Next, show that the time t is just under 14 seconds. That means we have to calculate the time. So how do you calculate the time? So which equation we have to use to calculate the time? That is very very important. So we know that when time t is equal to t seconds, the velocity is 0. The velocity of the boy is 0, right? So therefore, which equation we use to prove this is 0? Since we got the k value 11, use the same equation. So v is equal to 5 minus k by 30 into t. So in this we substitute t value as capital T and v value as 0, and k value is 11. So 0 is equal to 5 minus 11 by 30 into t. So from this we'll get the t value. So 11 by 30 into t is equal to 5. That implies t is equal to 5 into 30 divided by 11. So that is 150 by 11. So what is the value? So it is 150 by 11. So 150 divided by 11 is 13.63. So rounded it off like 13.63. So take 11, that is 13.63 seconds. So this is the time. So we got the time. Next, part C. Part C. Work out the average acceleration of the boy over the period of 0 to, that means from 0 seconds to the total time, from 0 to the total time t seconds they are asking. Okay, so we have to find the average acceleration. So find the average acceleration. So average acceleration, what is the formula for basically change in velocity by time? Okay, that means velocity at time t is equal to t seconds minus velocity when time t is equal to 0 seconds divided by the total time taken. So obviously it is very clear that, so what is the velocity when time t is equal to 0, that is 0. Okay, plus velocity when 0 seconds we already got in the first place, so that will take 2 seconds divided by what is the time we got, 13.63. So this is minus, right? So it is minus. So 2 divided by 13.63 is equivalent to 0.1467, rounded it off, minus 0.147 meter second power minus 2. So this is the average acceleration. Next, part D. Show that there is no time at which the acceleration of the boy is same as his average acceleration. Yeah, so this is little important, and see the logic there. So first condition, if you take, when for 0 less than or equal to time less than or equal to 1. So in this case, if you differentiate that with respect to time, so a is equal to dv by dt. So what is the value we'll get, because what is the velocity equation given, dy dt of 2 plus through 3, because 2 is constant, so 3 into 3, that means 3 into 1. So I'm directly writing the answer, it will be 3, right? Definitely. So this is not equal to minus 11 by 75 meter second power minus square, or 0.147. So this is definitely not equal to, right? So this means this is not satisfying. Next equation you take, for 1 less than or equal to time less than or equal to 1.5, again find the acceleration, that is equal to rate of change of velocity. So what is the second equation given? So 6 minus t square, again 6 is constant, so minus t square becomes minus 2t if you differentiate that. So this is, so minus 2 into t. If you substitute t values, what is the values we'll get? If you substitute 1, we'll get minus 2. Okay, if t is equal to 1, then acceleration is minus 2 meter second per minus 2. But if t is equal to 1.2, then acceleration is minus 2 into 1.2, which is minus 1.4 meter second power minus 2. Suppose in this, if you put t value as 11 by 150, then what is the acceleration you will get? Minus 11 by 75. So that means this is also not satisfying. Next, the third condition. Now for 1.2 less than or equal to time less than or equal to t, then what is the acceleration here? Again, rate of change of velocity, that is equal to, so here also when you differentiate the third relation, so first value is 5 is constant, so that will get 0. So for the second term, minus k into 30 by t, so minus k into 30 by t, k is a constant, but 30 by t is a variable, so that t becomes 1, so it will be minus k by 30 only, so that becomes now k value already know, that is minus 11 by 30. So this is also which is not equal to minus 11 by 75 meter second per minute. That means, so there is no time at which the acceleration of the boy is the same as his average acceleration. Okay, is that clear? Next question 7. Yeah. Now a particle moves forward or backward or along a straight line. The velocity of the particle is v meter per second. At time t seconds, that velocity is given by minus tq plus 75t for 0 less than t less than 10. Find the maximum speed of the particle. So write the given equation. So v is equal to minus t cube plus 75 into t. So what are the conditions given for 0 less than t less than 10 seconds? So differentiate this to find the acceleration. dv by dt, that is d by dt of v. So d by dt of what is v? Minus t cube plus 75 into t. Now differentiate each term separately. So this is minus, so t cube is 3t square, okay, minus 3t square plus 75 into derivative of time, dt by dt is 1. Therefore here acceleration becomes minus 3t square plus 75. Yeah. So to get the maximum speed, the relation given as like 0 less than 2 less than t. So let us take when time t is equal to 5 seconds. So because the average value I'm taking, because 0 and 10 seconds, the average time will be like 5. So during the 5 seconds, what is the acceleration? Or what will be its velocity during that time? So v is equal to, so v is equal to, what is the relation? Minus t cube plus 75 into t. So if you take like minus 5 cube plus 75 into 5. So what is the equation we get? So minus 5 cube minus 125 plus 75 into 5, 375. So 375 minus 125, which will be equal to 250. Yeah. So why we take the 5 here? That is the main important thing, right? How do you know that that 5 is that? Because maximum speed of the particle when acceleration should be equal to 0, right? That means when acceleration, if you take it as 0, then what happened to this equation? So 0 is equal to 3t square plus 75. Okay, so minus 3t square plus 75. That implies 3t square is equal to 75. Then t square is equal to 75 by 3. So that is equal to 25. So t square is equal to 25. Therefore t is equal to 5 seconds. So that is the reason why we use, when time t is equal to 5 seconds, we found the velocity that we get the maximum. Yes, because as time cannot reach 10 directly, right? The maximum speed of the particle is 250 meters, which we found by taking the acceleration of this particle is equal to 0. Okay. Again, I'm repeating. What is the reason we took time t is equal to 5 seconds? Because to get the maximum velocity, the acceleration should be 0. Okay, that is the reason why we did that. Yeah. Next, question 9. So a particle moves along a straight line. The displacement of the particle s meters at time t seconds is given by s is equal to 4t square minus 0.25 t cube when 0 less than t less than 12. Find the maximum speed of the particle. Work out the difference between the time when the speed is greatest and the time when the speed is least. So first write the given function. Given s is equal to 4t square minus 0.25 into t square. So first to find the maximum speed, that means we have to find the velocity. So velocity is equal to rate of change of displacement, that is ds by dt. Therefore d by dt of displacement, that is 4t square minus 0.25 into t square. So if you differentiate this, what will you get? 4 into t square. So 4 into t square becomes 2t minus 0.25 into again t square becomes 2t. So this becomes 8t minus 0.75 into t square. Sorry, this is t cube, right? So 3 into t square. So 3 into 0.25 will be 0.75. So 0.75 into t square. Just make a correction because this is t cube, not t square. Yeah. Now find, now we got velocity. Again, double time differentiate. Again, differentiate this dv by dt. That means d by dt of 8t minus 0.75 into t square. So if again differentiate this, so d by dt of 8t is like 8 into 1. So it is constant minus 0.75 into t square is becoming 2t. So that becomes 8 minus, so 0.75 into 2, that is 1.5 into t, which is equal to acceleration. Again, to find the maximum speed, what should be taken? So we should take acceleration is equal to 0. If you take acceleration is equal to 0, what will happen? So take a is equal to 0, that implies 0 is equal to 8 minus 1.5 into t. So 1.5 into t is equal to 8, then t is equal to 8 by 1.5. So what is the weight by 1.5? It is, you can also write as like 8 by 3 by 2, that means it will becomes like 16 by 3 seconds. Now substitute this one in the velocity equation. So what is the velocity function we got here? 8t minus 0.75 into t square. 0.75 into t square. Now substitute this value in that equation. So velocity is equal to 8 into 16 by 3 minus 0.575 into 16 by 3 whole square, and simplify this. If you simplify this, use the calculator, so we'll get like 21.3. Therefore v is equal to 21.3 meter second power minus 1. So this is the velocity they asked in the question. Work out the difference between the time when the speed is greatest and the speed is least. So first part we got maximum speed of the particle. So to get the maximum speed of the particle, the acceleration should be equal to 0, right? But what is given here for us? Displacement equation is given. So that's why first time differentiate that, I got velocity, and second time again I differentiate, I got the acceleration. Therefore acceleration I took 0, we got the time. So substitute the time in the velocity equation, that means, so you got the maximum velocity. So this is the maximum speed. This is the maximum speed. Now, when it comes to the second part, we have to find the time. So, time cannot be equal to either 0 or 12 seconds, right? This initial time and this is 12 seconds. But when the time t is equal to 0, what happened to the velocity of the object? You can look this equation. If you put time t is equal to 0, 8 into 0, it becomes 0, and this t also becomes 0. Then what happened to the velocity? Obviously, the velocity is equal to 0. That means if you take time t is equal to 0 seconds, then the velocity of the object is also 0 meter per second. So it won't gives. But if you take the value, maximum value, that is time t is equal to 12 seconds, then what happened to the velocity? You will get minus 12. So which is also 12 meter per second square. So what is the maximum speed we got in the above equation? 21.3 meter per second. So how do you get the 21.3? By taking acceleration as 0. Okay, that means the time. What is the time you taken for that? So the time when speed is maximum, that is equivalent to 21.3 meter per second. When this happens, when this is happened, when time t is equal to 16 by 3 seconds. That means this is the greatest speed. This is the time when the speed is greatest. Then where it is least, obviously this time. When time t is equal to 0, what happened to the speed? It is 0. 0 is the minimum speed, right? Yeah, the time when speed is least is the time when speed is least. So time t is equal to 0 seconds. They asked in the question, find the difference in time. Therefore, the time difference. Therefore, time difference is equal to, so 16 by 3 minus 0, which is equivalent to 16 by 3 seconds. So that is the answer for this question part B. Now we'll come to the 11th question. Question number 11. A train is traveling in a straight line. Elise is sitting on the train and is using her mobile phone, which is being tracked. The position of the phone measured from when the tracking began is given by S is equal to t square minus 2t cube plus 75t, where S is measured in kilometers and time is measured in hours. This phone is tracked for 2 hours, so time limit is from 0 to maximum time 2 seconds. Initially, the train speeds up, that means accelerating, but then it slows down again, that means decelerating. After how long is the train traveling at the fastest speed? Again, same thing. Fastest speed means maximum speed. So, maximum speed means acceleration should be equal to 0. So, but what is the equation given function in terms of displacement? That means 2 times we have to differentiate to get the acceleration. So, take the given function s is equal to t square minus 2t cube plus 75 into t. So differentiate with respect to time so that you will get the velocity. Therefore, d by dt of t square minus 2t cube plus 75 into t. So apply differentiation for each term. So t square becomes 2t minus 2 into t cube. T cube becomes 3t square. Already there is a 2 in front of it. So what happens? So minus 6t square plus 75 into 1, because derivative of dt by dt is 1. So this is the velocity equation function. Now to find the acceleration, again differentiate this. So dv by dt, that is d by dt of 2t minus 6t square plus 75. So things 2 into dt by t, that is 2 into 1 minus 6 into t square becomes 2t. Already minus 6 is there, so that becomes minus 12 into t. Derivative of constant 75 will become 0. So this becomes 2 minus 12 into t. This is the acceleration. So to get the maximum speed, acceleration must be 0. So in this, if you take acceleration is equal to 0, then 0 is equal to 2 minus 12t. That implies 2 is equal to 12t. So obviously time t is equal to 2 by 12. That is 2 ones are 2, 2 6 are 12. So 1 by 6 hours, because they gave time in hours and displacement in kilometers. Now we got time t is equal to 1 by 6 hours. So substitute this time t is equal to 1 by 6 hours in the velocity equation function, so that you will get the speed, maximum speed. That is 2 into 1 by 6 minus 6 into 1 by 6 whole square plus 75. So now what is the velocity? So 2 by 6. So this 1 by 6 square. So 2 by 6 minus 1 by 6 plus 75. So simplify this. So you'll get like 75.2 kilometers per hour. So this is the maximum speed it can travel. So this is the part B we got. Next, part C. When it is how far, find how far the train travels before it starts to slow down. Yeah. So part C. So we have to find. So it slows down. Obviously, it slows down when time t is equal to 1 by 6 hours, because that is the maximum speed attained. So that means once it attains the maximum speed, after that it slows down. That means t is equal to 1 by 6 is the maximum speed. After that it slows down. Therefore, distance is equal to. So what is the distance equation given? T square minus 2t cube plus 75t. Right? Substitute in that. T square minus 2t cube plus 75 into t. So in this place you can put 1 by 6. So 1 by 6 whole square minus 2 into 1 by 6 whole cube plus 75 into 1 by 6. So use the calculator and simplify that. Finally you will get something around like 12.5185 and so on and so on, like this. So rounded it off, three significant figures. So 12.5 kilometers. So before it's slowing down, the maximum speed it attained at 1.6 seconds. That's why I use the time 1.6 seconds to find the displacement it traveled till its maximum speed or before slowing down. So that's it from this exercise. So all the odd questions I explained here. When you find time, you can also do the remaining questions. Okay. Yeah, I hope it is useful.